Chapter 14, Gases, Part 4, Boyle's Law. Boyle's law states that the product of the pressure and volume for a given mass of gas is a constant, as long as the temperature does not change. The air pressure inside the inflated tires of an automobile is considerably more than the atmospheric pressure outside. The density of air inside the tire is also more than that of the air outside. Inside the tire, the molecule of the gas behave like tiny table tennis ball, moving disorganized and banging against the inner wall. Their impacts on the inner surface of the tire produce a force that average over a unit area, which will provide the pressure of the enclosed area. Let us suppose there are twice as many molecules in the same volume. This air density will be then doubled. If the molecules move the same average speed, the number of collisions will be double also. This means the pressure is doubled. So our conclusion is the pressure is proportional to the density. We have our famous equation which to calculate the pressure. Pressure equal density times gravity times height, which clearly demonstrate that pressure is directly proportional with the density. So when density increased, pressure also increased. The pressure and volume of a gas, on the other hand, enclosed in a space, are inversely proportional. If you increase pressure, the volume will decrease by the same factor. For example, if pressure is double, volume will be half. All of them will be governed by these equations. Pressure B1 multiplied by volume V1 will be equal to pressure 2 multiplied by volume 2, the final one, where B1 and V1 represent the original pressure and volume, and B2 and V2 represent the second or final pressure and volume as shown in the figure. So the product of pressure and volume of a given mass of gas will always remain the same, as indicated by this cartoon. Large pressure multiplied by small volume will be equivalent and equal to small pressure multiplied by large volume. Question: a piston in an airtight pump is withdrawn so that the volume of air chamber is increased 3 times. What is the change in the pressure? Because of the inverse proportional, the pressure in this case will be third of the original pressure. So the proper answer is B. Scuba divers must be aware of Boyle's law when climbing. As the divers return to the surface, pressure decreases, and thus the volume of air in the diver's lung increases. A diver must not hold his or her breath while riding. The expansion of the diver's lung can be very dangerous or even deadly. Question: if you squeeze a balloon to 1/3 of its volume, by how much will the pressure inside increase? Obviously, the answer that the pressure will increase 3 times. We have the inverse proportional between pressure and volume. So this is no wonders balloons break when you squeeze them. Another question: a scuba diver's 10.3 meter deep breathes compressed air. If she holds her breath while returning to the surface, by how much does the volume of her lungs tend to increase? In this question, the answer that atmospheric pressures can support a column of water of 10.3 meter height. So the pressure in a water due to the weight of a water along equal atmospheric pressure at depths of 10.3 meter. Taken into account the pressure of the atmosphere at the water surface, this means that the total pressure at this depth is twice atmospheric pressure. Her lung will tend to inflate to twice their normal size if she holds her breath while rising to the surface. Conceptual question: what does Boyle's law state?